already about it. Okay, and this chapters continues to be the chapter contains to be some part of with the physical aspect, that is just you have to think about the, as you have think in the stereochemistry, in the organic chemistry, here also you have to think about the some structures, some 3D structures, as we can see the 3D structures. Suppose in the online system in my front, I can see the CPU, the monitor, the blackboard, etc. These are 3D. Now here it is not in broad respect. Here we have to think it with respect to some arrangement of points. Arrangement of points, and the points are the it is not the points, it is that the cations, the anions, etc. Okay, now just think about, just make a imagination of the CPU. Just you know about the CPU in broad respect, the bigger one. So it having some corners. Just for example, the books, just imagine one books, here also some corners and also some lines. So the lines is the we can tell it as a bond, and the corner, it can be called as a point, because from that corner the dimension, that the geometry is fixed at that corner. If the corners or the bond angle is different, suppose in the case of book, if the bond angle in between the two line, the two corners or two edge is different, then the shape will be different. So here the shape, you are familiar with that word from the chemical bonding, that the shape, and the geometry is also familiar to you with respect to the stereochemistry of organic molecules, and also the shape from the inorganic molecules. Okay, now here in that chapter, here it is specifically for the solid, because here is a just the 11 and 13, out of 13 out of total periodic table elements, there is only 13 or 14 elements which are in the form of gas or liquids, but except that 13 elements, all the elements are in solid form. Okay, now as they are in solid form, here they the arrangement of that point, here the point means the metal ion, here the point is the metal ion, which is arranged in different way. Okay, so there are three states, that is solid, liquid and gas. Okay, and the liquid, the inter binding force or intermolecular force is maximum in case of solid, you know it, and for this it can be represented in a definite shape. And out of these three states, only the liquid and gas can show the fluidity, but except solid, because solid does not show such kind of fluidity, because of the bond length is very static and a strong intermolecular force. They are so rigid. Already you come to know about some intermolecular distance, which is maximum for gases, and it is less in case of liquid, and then it is very negligible in case of solid. Okay, so these are the intermolecular binding forces, intermolecular bond distances. These are contained here, comprises here to make the structure. Now coming to the next state, that is nowadays the superconductive solid are also made. What is the use of it? That is superconductive solid. Here is the superconductivity is the property of some specific elements. Now these superconductive solid are synthetically made, and when they are made at a temperature below that temperature, their resistance is negligible or nil. So there are two types of superconductive metal, that is LTSE and HTSE. LTSE means low temperature superconductive, and HTSE means low temperature superconductive, high temperature superconductive. LTSC and HTSC. These are the superconductive material and synthetically produced. These are about, and amorphous silicon. Amorphous silicon is the photoactive, which is used in the photocell from the photo energy to electrical energy. That is amorphous silicon. Now these amorphous was will be discussed later on. Now come to the another one, that is what is crystallography. What is crystallography? Now I can bisect these two words, that is the graphy here is the study of some definite way, study with respect to some definite way, that is called graphy. That is the X-ray or the okay. So crystallography is the study of crystal. Study of crystal. Now what is the crystal? Coming to that crystal. What is crystal? It is the arrangement of that point so that it gains an geometry. It is the arrangement of that point. That is the point in that is here the metals. The arrangement of metal atom in its solid state, which is called as crystal. So arrangement of metal ion or arrangement of metal atom to make a definite shape, and which is called as crystal. So crystal is having a definite dimension. That means it having some fixed number of edges, some fixed number of points, and so that it makes a total geometrical shape. Such, just for example, think about a cube. Think about a cube. Now here these are the edges, these are the edges, these are the corners, these are the corners, and these are the faces. So this is important. This point, this edge, and another one is that the face. How many faces are there? How many corners are there? And with respect to this, we can calculate also the density of that. So the study of crystal is called crystallography. The branch of chemistry which deals with the study of crystal is known as crystallography. Okay. Now coming to some general characteristics of solid state. Now the general characteristics of solid state are known to you, that is intermolecular forces are maximum here, the solid having rigid and definite shape. Here definite shape, that means here you will come to know about the some cubic close packing, the hexagonal close packing, etc. And also some point defects are there, and some arrangement, that is the how octahedral hole, the tetrahedral hole are developed here. These are also one part of the crystal. These are also to be discussed. And intermolecular distance is very short, because as the binding force will be maximum, intermolecular forces will be strong. Now next one, solid maintain their volume independent of the size and shape of the container in which they are placed. It is due to the, suppose just think about one crystal of an sugar, crystal of a sugar, or a crystal of a sodium chloride. Now the sodium chloride is in crystalloid form, but we can see it is the particle, that is the aggregation of that particle in a we can see it in a dust like shape. Okay, but in the, if we take one single particle out of these, and in between these, here is the arrangement of the sodium and chlorine is definite. So this is called as the fixed position or fixed shape. Next one, solid have high density, you know already. Particle in the solid are fixed and they can oscillate about their mean position. Here the oscillation is maximum in case of gases and the medium in case of liquid, and very negligible in case of solid. But when we heat it, when we get it, then the kinetic energy of the particles is increases, and the oscillation also increases. Intermolecular the interatomic distance at that the interatomic binding force becomes loosened, and the solid is converted to the liquid state. Another definition may be there to define the solid or liquid, that at room temperature at a normal pressure which exists in the solid form is called as solid, and which exists in the melting point is above the room temperature at normal pressure is called as solid, and the at room temperature and at normal pressure the melting point is less than that of the room temperature is called as the liquid. So here is the independency of their size and shape according to their structure, that is the shape. Solid are almost incompressible. What is the meaning of incompressible? That gases are compressible, that is increasing pressure we can compress the gas, but as they maintaining a very short distance in between the atom, so it is not too much compressible with respect, so this is less compressible. And solid have high density due to of close packing, of atoms in crystal. Close packing of atom in crystal, it is due to it is the reason for its high density. Okay, next, particles in the solid state are fixed and can only oscillate about their mean position. Okay, discuss. Solid have negligible fluidity as compared to liquid and gases. What is the fluidity? Is to tendency to flow freely. Flow freely is called as fluidity. But here the intermolecular forces or interparticle forces basically is so strong that they cannot move freely. But in case of the liquid, it is very easy to move freely, so they are fluid in nature, but here the fluidity is negligible here. The diffusion of particle in the solid state is negligible. Diffusion means it is the spreading of the particle from one place to another. It is maximum for gases and it is minimum for fluid, because if we place one solid materials at one corner and we can just see it, it's we can feel it, but we cannot get any type of smell or etc. Okay, so these are the general characteristics of solid state. So from the characteristics, the solid can be defined. From the characteristics, the solid can be defined. What are the characteristics of the solid? I just discussed, and the solid may be defined as, it is, first of all, it is the form of a matter, and the constituting particles, it may be the ions, atoms or molecules, are so closely packed that they cannot easily move past from each other. So they are the constituting particles when they are not free to move easily, that they cannot change their position easily in normal state, then it all be called as a solid. The constituting particles may be atoms, it may be ions, or it may be molecules. The form of matter had definite shape as well as definite volume. So these having some specific characteristics, that is the lock at their position or do not free, is not free. The constituting particles are not free to move due to interparticle binding force and maintain a fixed shape, then it would be called as the solid, and the constituting particles may be atoms, ions and molecule. So when atoms, ions or molecules are the arrangement is so that they are not free to move due to the interparticle binding forces and maintain a fixed shape and also volume, then it would be called as a solid. So it is the definition of solid. Now coming to the next part, you know the definition of melting, point. Okay, now coming to the melting point of some solid, suppose the nitrogen, oxygen or nitrogen, the melting point for oxygen is 55 Kelvin, that is 190, round about 190 degrees centigrade. For nitrogen it is 63 Kelvin. For ethyl alcohol it is 159 Kelvin, and if we cool down ethyl alcohol at a temperature that is 169, that is 114 degrees centigrade, then it would be a solid. And ice, we know it that the melting point of ice is 273 K. For sodium it is 371 K in the Kelvin scale. In case of oxygen and nitrogen, they are non-polar because there is no polarity, no electronegativity difference, and as they are in gaseous form, it is due to the very weak interparticle. Which one? What is the definition of solid? Just said, oxygen, the melting point of oxygen, it is 55 Kelvin. Okay, because it is very low with respect to our normal temperature, that is 0 degree centigrade. Here it is in Kelvin scale. Now both oxygen and nitrogen, they are in gaseous because the intermolecular forces, that is van der Waals forces, interparticle forces, these are very negligible in case of oxygen and nitrogen, so they are gas at room temperature. Okay, and the melting point are also very low. But in case of ethyl alcohol, it is at room temperature, it is liquid. You can see that ethyl it is intermolecular forces are due to the hydrogen bonding. So this is also a kind of bonding, that is intermolecular forces. Okay, now these are the, and the other one, that is sodium, magnesium, you can see there is a large difference in between the melting point of sodium, it is just 371 Kelvin, but in case of magnesium it is 920 Kelvin. Okay, so sodium, because of its low melting point, it can be cut by a knife, and the particle force, that is the intermolecular binding force, is not so hard, so it can be cut by a knife. Now coming to the types of crystal, types of solid, not crystal. Crystalline, amorphous. crystalline and amorphous solid. Both are the solid form, but crystalline, they are found in a very small particles, but the amorphous is sometimes it may have some definite shape, but sometimes it may be in the powdery form, okay, because they are deformation of shape or deformation of that bond angle or the bond length, then it will becomes the amorphous one, okay. Now coming to the crystalline solid. So in the crystalline solid, in which the constituent particles have a regular orderly arrangement throughout, and it gets repeated again and again, resulting in a definite pattern. So what are the characteristics of the crystalline solid? The constituent particles have a regular orderly arrangement. Regular orderly arrangement. It is in crystalline solid. And next one is that it is repeated again and again to form a definite pattern. This arrangement is repeated to make a pattern. So just you have given three colors of ball, and you have to make two colors of ball, and then you have to make one just in the cubical form. So you will place it you will place the ball according to its corner, etc. Okay. Now you can place the ball according to your wish. Suppose there is a red ball, here is a black ball, okay, here is a black ball, here is a red ball. So in this arrangement, so here this is one unit, this is an unit, okay. Now here you would be supplied to make one unit, you would be supplied 1 2 3 4 5 6 7 8 balls of two color, and it would be divided by 2, that is 4 of red ball and 4 of black ball. So here according to your wish you can arrange it, but in case of the crystalline one, it is the arrangement is such that it should be repeated. Suppose if these two are the red balls, then again another unit will be there, these two also will be of red ball, and if you place black ball here, then it would be one black ball. So this is called the repetition. This arrangement is repeated to make a pattern. So the red ball, again the red ball, again in the unit there also be a red ball. So unit, the numeric, when n number of such repeated units is there, then it forms a crystal. So n number of repeating units is there, then it would be called as the crystal of that compounds. So this is the crystal. Now some examples of crystal, very familiar example, that is sodium chloride and copper sulfate. Now copper sulfate pentahydrate, here is the arrangement there, that is the copper is the center and 3 sulfate SO4 sulfur is there, and oxygen here 1 molecules of H2O is there. So these arrangement, that is again it would be 1 copper oxygen, again in this way it would be 1 copper, it would be 1 copper. So this is called the definite arrangement. In case of sodium chloride, here it is the sodium, it is the sodium, it is the chlorine, it is the chlorine. So this would be chlorine, this point would be chlorine, this would be sodium, it would be sodium. So this is called the definite arrangement. Some examples are given. Now coming to the amorphous solid. Now the crystalline solid have long range order. What is long range order? Just as they maintaining the definite pattern, that is this pattern, that is they have a long range, that is sodium, 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 sodium. Again in the right side it would be sodium, so it would be a long range order. Okay, so the arrangement is such that in a line there is a series of that particular atom. Next, coming to the another one, the amorphous solid. Here the constituting particle do not possess the regular arrangement throughout. No regular arrangement throughout. What does it mean by throughout? Okay, now in case of amorphous solid, just sodium, 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 it is a numerous number, that is a huge number of chain is there. But here in case of amorphous one, just after a particular unit, it may be one specific unit, that is n equal to 1, n equal to 1, that is one discrete unit, or it may be just think about one number, that is just think about 50, n equal to 50. So when n equal to 50 will be there, then this part is assumed to be a solid one, but after that, after the 50 unit it is released, then it would be called as the mixture of the solid and also that is the crystalline and amorphous, because these unit, that is the 50 units, work as the solid part just for the crystalline part, but when it release, then it would works as a amorphous part. So here you will see the no regular shape is there, and okay, so this is the definition. So there would be no repetition according to broad respect, there is no repetition of that unit. So the amorphous solid, no regular arrangement throughout, and this is called, the crystalline solid is called true solid and also long range order, but it is short range. It is the short range order. Okay. So one example of such that the quartz glasses are example of amorphous solid. Okay, so on the next day we will make a distinction of the crystalline and amorphous solid. Okay. Anubhav, Priyangshu and Akash. Okay, so that's all for today's